To understand the formation and evolution of the Milky Way, we need to characterize its stars. This means knowing their positions, their movements, and their astrophysical properties, such as the mass, the chemical composition, and the age. In fact, the mass is one of the fundamental properties, along with chemical composition, that controls how a star evolves. It controls which chemical elements will be produced in its core. It will also control how long a star will live for, so its age, and it also controls what matter it will eject into the interstellar medium. This means that the mass of the star also controls how galaxies evolve. But measuring mass properties for most of the stars we observe is not a very easy task. We may be lucky that the star is an observable binary system, and therefore we would have dynamical information, which would allow us to apply Kepler's law to solve for the masses, and thus the mass would become an observation. But in most cases, the stars are isolated sources, or appear so, and we cannot use this approach. The mass is not observable. This means that we rely on our theoretical knowledge of how stars evolve in order to determine their mass and then their age by comparing things that we can actually measure from stars. For example, we can measure radii or temperatures of stars, and we can predict these same quantities from the theoretical models. Therefore, by comparing the observed and the predicted quantities, we can infer, but not measure, the mass and the age of the star, or what they are likely to be, according to what we have measured and how well we have measured it, but also depending on the assumptions used in the model. Gaia observes many types of astrophysical data, the positions and movements of stars, the medium resolution spectra in the infrared, which are known as the ORVS, and also the low resolution BP and RP spectra that cover the full visible wavelength. From these data, we can extract things like temperatures, the metallicities, and surface gravities of stars. These are things that I call observable properties. My job in Gaia is to take these observable properties and convert them into masses and ages. I lead the work package FLAME, Final Luminosity Age Mass Estimator, which produces, as the title states, the luminosity, mass, age, along with other stellar properties such as the diameters of stars. I use the temperatures and metallicities derived from other modules that exploit the spectra, along with other Gaia observables to derive the luminosity and the diameters. Then these are compared with stellar models to estimate the masses and ages. In Gaia Data Release 3, 137 million masses and 128 million ages are estimated.